So let's talk about running fixes. I'm Grant Hedefin, Global Director of Education for NauticEd. And running fixes is completely simple. A lot of people have made it really complicated. I'm just going to show you how simple it is, and I'm going to do it in Adobe Illustrator just so that we can get all the lines directly accurate, and I can show you some cool stuff, and then you'll actually get a better understanding as we do it this way. Running fix, basically all it is we've got just one object out in the ocean, and we can get a line towards it, but that's the only object we've got, so we can't do a fix off 2 points. So we're going to do what's called a running fix, and essentially it's do a fix, a sort of a fix now, like on a line, and then we'll wait till a little bit later and we'll run another line to it, and then essentially we've got 2 points because it's 2 different points in time. So here we are in a boat, we're just running along, and the heading is 150 degrees true, and we're doing 10 knots now. I'm going to do everything in true. If you want to learn how to convert from magnetic to true, we've got other videos and things like that in our coastal navigation course. But for now, just to make things simple and faster, we're going to do everything in true degrees. Means everything is off the chart. And if we shoot a compass line, then we're going to convert it to true. So here we are going along in a boat, and at 9 o'clock, we find that Johns Reef Lighthouse is at 112 degrees true. Now, we drew that onto our chart using our Breton plotter. And so this is a really cool device. If you don't have one, get one. It's absolutely incredible. We can find any angle very, very fast on any line that's on the chart. And if you've seen what I've done here, we've dialed in 112 degrees right here onto the rotating protractor. So there's 112 right there. And we've aligned the rotating part of it with the north, south, east, west grid. So this is perfectly up and down, north, south, east, west. And then we've just rotated this around to be 112 degrees, and so therefore we can plot a line exactly where the boat is. All right, so we know that absolutely 100% we have to be somewhere on this line, and the time is 9 o'clock, and we're heading 150 degrees. So this line here is 150 degrees true, and I pre-plotted that using the Breton plotter as well. So here we go, 9 o'clock. We're somewhere on this line. What we're going to do is wait for a little bit of time to pass, and in this example we're going to wait till 9:15, and we're going to measure the angle direction to Johns Reef at 9:15. So what's pretty cool is we know at 9:15 we are absolutely somewhere on this line, and at 9 o'clock we were absolutely somewhere on this line, and we know that we're traveling at 10 knots at 150 degrees. So in 15 minutes we know we're going to do 2.5 miles. So we're just going to plot, we're going to pretend we're somewhere on this line here to start off with, and we're going to plot 2.5 miles directly out in front of us, and we should be on this line, right? But we're actually not, and that's okay, because all we have to do is take this line here and make sure that it meets both conditions. So if the boat was here at 9 o'clock and here at 9:15, it meets both conditions, and so that means that is where we are, and this would be called a running fix. So I'm going to show you how really easy it is just to transfer that line to there. So all we're going to do is take this line, which is your first line, and I'm just going to copy and paste it, and you can do this on your chart. And what we're going to do is just drag a line to the end of that 2.5 nautical miles. So there we are. Now, here's the very cool part. All we have to do is draw a line exactly parallel to this guy that meets that condition. So that's kind of magic. So if I drag, I'm just going to copy and paste to that exact intersection point right there. That is the definition of exactly where we are. I'm just going to drag this up there. So we must have been there. And that is running fix. It's super cool. It's super easy. So all the trick to it is just this little wee piece of magic, right? So it's dragging this line down to there. Now it's obviously drawn. It's drawn in there. So we're just going to draw a new line, right? So it's this line here is exactly parallel to that line. Okay, that is, just trying to keep things simple here. Oops. Okay, so that line is exactly parallel, but we took it right to the end of this first estimated line, and then that created a cross here with there, and then we just moved that one, moved this line here up to there. And that's it. That's the running fix. It's so simple. Now, here's the unfortunate part about running fix, and people talk like they're absolutely magic, and they are, except for the fact they don't take into account current. So let's take a look. I'm going to put in, for example, a current arrow, and this is current is flowing south, for example. And what we're going to do now is we're going to draw our current triangle. Okay, so this is a current triangle, and I'll just put it out here so you can see. So this here is that's the current vector, all right? Your water track vector, this is your water track vector, and this is your course over ground vector. So remember, course over ground is where you actually are. You try to go in this direction with your boat. You get pushed off by current, and you do a course over ground. So this is that vector. So let's go put this one up here. Now remember, the water track is 10 knots, okay, and it's heading at 150. That's what the boat is actually doing. So, we're doing that, right? Here we are. So we're on this line right here. And so that's our water track vector. Now here's what happened was our current, so that's the water track, and this is our course over ground, right, this line here. Now remember, the course over ground is actually where you are, so we actually might have been there, but we're not actually here. We're on this line. So what we have to do, it's very simple, just to understand all this. So that is now your course over ground, and that is your water track. So you were here and you went 10 knots at 150 degrees. Your current pushed you off course, and so you ended up here. So now actually this here, from here to here, is your track. That is your track. Okay, now here's the thing. Actually, you don't know that that's the real current, right? We just made that up for this example. So your current could have been even more. So your current could have been, a lot more. Could have been like that, could have been like that, could be like that. Now, if it was like that, right, that's fine. The conditions are met, we were there and there, but the current could have been like that. We just don't know what the current is, right? But we know we're going to get pushed off by the current. So, for example, let's just go back and let's take the example we just sort of set up, right? So we thought that this was the current. We're just making this up, and that meets all the conditions for that current. Okay, so we would have to be there. Now, But the cool part is, because we don't know that that's the current, but we can actually gain a real track. So again, remember, look, if there was current, we wouldn't end up in this spot right here. We would end up in this spot, and we would have started from here. We would have started right there and ended up right there if we knew that that was the current, but we don't know what the current is. So what's cool about it is, though, for the next 15 minutes, we're pretty sure that the current is going to be the same as it was in the last 15 minutes. So that's not a bad assumption. So let's make that assumption. So what we're going to do is we're going to move this down here, and we are going to say that since this is our course over ground, from there to there, we will be on this track here at 9:30, and we are on this track at 9:15. And there's only one line that can meet that condition. So at 9 o'clock, we were on this line here. And at 9:30, we were on this line. I'm just going to make this line green and a bit thicker. So if there was this much current, we would be traveling along this line. Now, here's the trick to this, and this is why these triangles work really well, is the distance from here to here must be exactly the same as the distance from here to here. And if you do these triangles, it actually is. All right, so I'm actually just going to measure this line from here to here and this line from here to here, and we'll just sort of prove to you that it's exactly the same distance. So look at that. Okay, so the distance from there to there is exactly the same as the distance from there to there. All right, so that's just the nature of putting these two triangles together, and it's actually sort of independent of the current. And I'm also going to prove this course over ground line here in another manner to you, which is just sort of shows you don't actually need to know the current. So let's just assume that the current was a lot different. Let's just make it that way. All right. So remember, this is our water track right there. So this is still our water track. This is our new current direction is in that direction. All right. There it is. It's going in that direction. So this is our new course over ground line. So right, the course over ground has to meet the conditions of this one and this one. So let's just take this triangle, and it has to meet the conditions right there. Get rid of that line. Okay, so course over ground is there and there. Water track is there and there, and that's the same distance as this line, right? And then that's our current. Okay, so what we're going to do is delete that one. Now this same triangle has to happen 15 minutes later, so copy, paste. All right, and it has to meet the conditions. So there we go, right about there. Okay, so starts there at 9:15, ends there at 9:30. Okay, now we're not actually there, but this meets the condition. So what we're going to do is draw a line from this one now down to this one. Okay, so let's make that a bit thicker and green. And voila, this line here is exactly parallel to this line here. But the current was completely different. So what we have proven is that from this, the current can be really anything, but using these conditions, you absolutely know the course over ground. Now again, you don't exactly know where the course over ground is, but you know what the course over ground is, all right? And you know what's pretty cool is you can sort of assume, well, maybe the current is only, you know, 2 knots maximum or 1 knot maximum, whatever in the area you are. So it's going, you can draw a 1 knot sort of circle around yourself here and there, and you can sort of say, okay, well, we're definitely in this zone, but I know for a fact this is my course over ground, and I know pretty much where I am, no matter what the current is, right? And if the current was 0, look, not a problem. You'd be following exactly along this line here, because that's your water track that meets the course over ground. So what's cool about it is now we've been able to totally get our COG line out of this. Okay, now, still don't know exactly where we are, but what's kind of cool about this is, you know, we thought we were doing this over here, and what I'm going to do is just sort of show you the ramifications of what if, yeah, there were a couple of rocks down over here. So that ain't cool. We're heading in this direction. We thought we were heading in that direction, right? So now we've got a better idea of our course over ground. It's just another variable that we can throw in using a running fix, right? So one for 15 minutes and then another one for the same amount of different distance afterwards. And you don't have to be 15 minutes, it just has to be the same length of time to make things a lot easier. So just remember, running fix, really cool, doesn't take into account current, but it is pretty cool and very easy, and the magic of it is just copying this line here down to parallel this line down to this one right here. And then it's just magic, right? So when wherever this new line here meets with this one coming in, you just parallel this line over to here, and that is your running fix. So it's just so simple. Okay, now do another one for another 15 minutes. Draw in any triangles, doesn't matter. And then what you can do is find your course over ground, because it has to run from there to there, because these have to be the same distance. So look, if you change this angle in any way, right? So now that distance from there to there is not the same as that from there to there, but it has to be the same distance because it was 15 minutes on each side and nothing changed, no speeds changed. So what's cool about it is that we've totally been able to get our COG direction out of this. Okay, so it could be this one here, it could be this one here, but we actually know the direction of the COG, whereas before we were making an assumption that there was no current in order to get this line here. Now we know, well, okay, so there's probably going to be some current, and we can actually get a COG line direction by just doing these actual triangles here. So that's an extra piece of information just by doing that secondary line of position. Right, so actually I'm going to really dummy it down for you, make it super simple. So let's just clear some things out here. I'm going to grab this COG line that we know that's the direction. It's always going to be that direction. And because it has to be that direction because of these measurements here, right? If these lines were different, then that direction would be different of the COG, but it has to be this way. Okay, so let's just get rid of some stuff here. Now, what we've done is, let's say we've just now done these lines. And I'm going to just on here, just do any random line. I'm just going to draw that line from there to there. Okay, now I'm going to parallel that line down onto this one. Okay, so this line here meets these conditions, going here to here, and this line meets these conditions going here to here. Watch this. I'm going to draw this line here. And then that line is going to be perfectly parallel to that. Okay, so we did all those little triangles. I did those triangles just to show you about current and things, but wow, this is incredibly simple. If you've got 3 lines of position, so this one at 9 o'clock at 1:12, then we got this one here at 9:15, and then we got the third one here 9:30 time, so 15 minutes between each one. So we know the distance traveled between here and here, between this point and this point, is exactly the same as this point and this point, but we don't know where they are. Okay, so we're just going to take some random line. I'm going to do it again. Let's take that one out. Let's just do a different random line. It's just a random line. Okay, I'll get rid of that one. And I'm just going to parallel this line down to here so that it meets the conditions. All right, and then I just draw a line straight from there to there. And that line is going to be perfectly parallel again to that one. So it really doesn't matter what the what the current is, right? Now, we don't know exactly, again, where this COG line is. It could be, you could be right there. Your boat could be, your boat could be right there. Okay, but we don't know, and we're never going to find out. But what we do know is that this line from going down this way is the direction of travel. We're just not going to exactly know it is where it is because of the current. Now, this is a lot better than just one, because before we said, well, this is our estimated position based on the water track and assuming the current was 0, which could be, maybe, maybe not. But what we now know, at least, is that we're traveling in this direction right there. Okay, so we're going to turn your boat, and that's going to be your direction of travel right there. All right, so you're just getting one more piece of information out of it. And again, because of these rocks down the bottom here, you definitely want to know, what direction of travel you are traveling at versus just sort of assuming that there was no current. All right. So they say repetition is key, and you can stop this video now if you want to, but I'm just going to repeat everything just a little bit faster, but we'll just go through it one more time so you really get it. So what we've done, we've got a boat going along, we know it's heading, we know its traveling speed, and at 9 o'clock we measured that it was 112 degrees to John's Reef, and that boat could be absolutely anywhere. So we know that it's on this line here somewhere. All right. Now what we're going to do is we're just going to transfer this line down to the 2.5 nautical miles that we've drawn, because we know at 9:15 we've taken this shot, okay? And we know that this isn't on the 9:15 line. We want it to be on the 9:15 line. Really simple how to get it there. All we do is we just parallel this line down to the end of the 2.5 nautical miles to this point right there. Now what we do, just parallel this line over to get to this magic point. The magic point's right there, so just parallel that one over, and we're going to put it right there. And that, if we had no current, we would know that our boat is right at that point at 9:15. That's our estimated position. Now there's current, bound to be. So what we're going to do is just take any random line from here to here. That's just a random line. I'll make it green. All right. Now we're going to parallel that line down. Super easy. Copy, paste, and we're going to make it so that it meets the conditions. All right, so this one met the conditions. It was there. 9 o'clock it was on this line, and at 9:15 it was on that line. That's perfectly valid place for it to be. At 9:15 we met the conditions. We were on this line, and at 9:30 we're at that line, and these two lines are exactly the same. Now what we're going to do is draw a line between this one and this one, because that makes this point from here to here exactly the same distance as this point here to here. All right, that's just the way it works. Kind of magic. There we go, and look at that. That distance is exactly the same. All right. Okay. Now, and just as before, this was the line we sort of kept, and it is exactly parallel. So again, these random lines just don't even make any difference. All right. And again, so now one more time, this is not your actual course over ground. Okay, you still could be anywhere along here. We don't have that piece of information, but you know now from the secondary line of position at 9:30 that your boat is now heading in this direction. That's about parallel to that one, kind of close enough. And in actual fact, we could bring in our Breton plotter and let's just find that direction as an extra bonus. Okay, so we're using the Breton plotter, and let's go down to here and look at this right here. So the rotating part is aligned exactly with the grid, and we've rotated the rectangular part, and we're picking up this line here, which is 166. So this line here is 166, and so we can label this as, we know 166 degrees true. Get rid of that line, it's just some random line. So we know we're traveling at 166. Our heading is 150. Our course over ground is 166. But be careful, we are not here. Okay, we could still be anywhere along here. But it's a heck of a lot better than saying we are here when we're quite possibly not. In fact, this line here actually proves it. All right, so if the current had been in the conditions that created this line, we would actually be here at 9:15 and here at 9:30, going right towards these rocks. Thanks very much for tuning in to NauticEd to this video. I really hope you enjoyed it. It was quite technical, but I really do think we dummied it down and made it easy to do this. Probably going to have to come back to this every now and again. Fortunately, this video is embedded into the NauticEd coastal navigation course, and so you'll be able to take that course anytime. Right now, the cost of that course is $39. So get the coastal navigation course. We talk a lot more about all kinds of other navigation, and if you really didn't understand this this presentation, you probably should just dive right into the coastal navigation course, and we start from very basics and we bring you up to this kind of speed so that you'll know navigation very well. All right, thanks for tuning into NauticEd.